Right, so here's is 2015 paper 2, and this is question 10, and it's all about the length of an arc, and with the length of the arc you're having to calculate the length of the pendulum, and we know that the pendulum, well, the length of the pendulum is obviously the radius of that circle. Okay, so we're just going to be using the length of the arc formula. We'll have to be changing the subject in it, and then we'll be able to get the answer to the question. So what we'll do is we'll, first of all, I would even just label what we've got. So the length of this arc, A to B, so this is 28.4 centimetres. I've already got this angle, and pretty much we're ready to go. So first thing I would do is just write in the formula. So we've got length of arc equals, and we just call any angle that's the angle of the sector, just call that theta if you want, 360 degrees, okay, and it's times pi, and also times the diameter, which is obviously double the radius. So you know that the circumference of a circle is pi d, so the length of the arc is theta over 360 times pi d. Now we can actually start putting some of these values in. So what we know is we know the length of the arc is 28.4. We know that it's 65 degrees, just double check. 65 degrees. We know it's under 360 because it's a proportion of the whole circle, and that's times pi times d. Okay, so we're looking for d. Now remember, when I write that part of it, that's the same as just saying 65 pi d divided by 360. Okay, so that's just the same as that. Now what we want to do is just rearrange the subject to the formula just so we actually have it in d, and then we can work out what d is. So what we can do first of all is if we actually just, we'll times this side by the 360 to get rid of this 360, so we have to times this side by 360. So remember, this is the exact same format as this. So what we end up having is we end up having, change the colour back to black, is 28.4 times 360, and that is going to equal to 65 times your pi d. Now, we're now wanting to get rid of that 65, so you do the opposite of what's happening. So it's been, this diameter's been times by 65, so just do the opposite. So this time we're just going to divide by 65, and obviously we have to do it to the other side. So what we now do, or what we now have, is we've now got 28.4 times 360, and that's going to be divided by 65. Okay, and that is equal to pi d. Now I'm going through this, I'll just minimize that. I'm going through this in a lot of detail. Okay, now we still to get rid of that pi, so again what we'll then have to do, and I mean in theory in one go you could have said divide by 65 pi, but we're just taking this slowly, so divide that by pi, divide that side by pi, and that's us done. So we've got 28.4 times 360, and that's going to be divided by 65 pi, and that's going to equal your diameter. Okay, now this is paper 2, so it's a calculator paper, so you would have to then think about, grab and hold your calculator and typing this in, right? So what we've got is if we go 28.4 and then we go times 360, right, we'll see what number that equals. Then I'm going to then divide that number by 65 pi. So I'm just going to go divides, I'll just open the brackets and I'll say 65 times pi, close the brackets and then press equal. So what we've now got is we've now got the diameter equals It's 50.067, just going to say 50 centimetres. Okay, but remember that's the diameter. The length of the pendulum is essentially, that's the radius of the circle. So what you then have to do, it's a strange spell in a radius, what you then have to do is then divide that by 2. Okay, so basically R equals your 50 divided by 2, so that gives you the length of pendulum, which is the radius, is equal to 25 centimetres. And that should be your answer for that question.